The audio
Imagine your
features a
immune
rhythmic,
system as an
technological
elite
hum of a
team of
command
bodyguards.
center with gentle, futuristic chimes and a soothing computer voice stating,
Their mission is to destroy viruses, bacteria, and other dangerous invaders. But sometimes they make a terrible mistake. They sound the red alert and launch a full-scale attack. The supposed enemy: a grain of pollen or a tiny piece of peanut. Neither is trying to harm you. Yet your body may sneeze, itch, swell, or struggle to breathe. That overreaction is what we call an allergy. Why attack something harmless? The story begins one ordinary morning. You welcome the fresh spring breeze. Moments later, your nose starts tingling. Another sneeze and another.
Achoo. Achoo, achoo, achoo.
Your friend remains perfectly comfortable. The same air enters both bodies. Yet only one body sounds the alarm elsewhere. A child first tastes peanut butter. Nothing unusual happens. Months later, another bite triggers hives. A cat appears. One visitor smiles and reaches forward. Another begins coughing before touching the animal. Allergies make harmless surroundings feel strangely personal. Almost anything can seem suspicious. Pollen, food, medicine. Latex and insect venom can become triggers. Pet proteins can also trigger symptoms. These triggers are called allergens. Most people encounter them without serious trouble. An allergic body interprets it differently. This is not simply weak immunity. It is often an unnecessarily aggressive response. Powerful guards their target is wrong. Before an allergic reaction, the immune system must recognize something suspicious. This learning process is known as sensitization. The first encounter may cause nothing. Behind the scenes, however, the immune system may be taking notes. It remembers one protein as dangerous. For many immediate allergies, the body produces antibodies called immunoglobulin E. Scientists usually shorten that name to IgA. Think of IgA as a collection of highly specific wanted posters. Each poster recognizes a particular allergen. These antibodies attach themselves to immune cells, called mast cells. The mast cells remain stationed throughout tissues, such as skin and airways. Now the alarm system is ready when the allergen returns. It can connect with those waiting antibodies. The mast cells rapidly release chemical signals. Histamine is one of the best known. Histamine causes swelling, redness, itching, and mucus. Blood vessels widen and become more permeable. Fluid moves into surrounding tissues. Your nose becomes blocked. Your skin develops raised, itchy patches. Your eyes turn red and watery. Yet these reactions use ancient defensive tools. Mucus can trap and remove unwanted particles. Sneezing blasts material from the nose. Coughing helps clear the airways. Vomiting can rapidly empty the stomach. These responses can repel genuine threats. During an allergy, however, they are often aimed at the wrong visitor. Symptoms depend partly on the entry point. Airborne pollen reaches nose and eyes first. Sneezing, congestion, itching, and tears follow. An inhaled allergen may also worsen asthma in susceptible people. Food allergens enter through the digestive system. It may cause hives, swelling, vomiting, or other symptoms. Skin contact can create a different pattern. A new watch band leaves an itchy red outline. A cosmetic causes a rash 2 days later. Not every allergic response happens immediately. Allergic contact dermatitis usually involves immune cells called T cells. Its delayed reaction differs from a typical, immediate IgE response. Allergy is not one single mechanism. It is a family of immune mistakes. Why do certain people make them? There is no single answer. Genetics can increase a person's tendency to develop allergic disease. Allergic parents can pass down higher risk. But inheritance is not destiny. Two siblings can grow up together and develop completely different allergies. The condition of the skin and airway barriers also matters. Damaged barriers may let allergens meet immune cells more easily. Timing matters. The developing immune system learns from countless early encounters. Food microbes, animals, pollution, and infections all shape that education. Researchers are still untangling those influences. Simple explanations rarely capture the whole picture. For decades, people blamed modern cleanliness alone. This became the famous hygiene hypothesis. The real idea is more complicated than having an overly clean house. Scientists now study the variety of microbes surrounding and living within us. Microbial exposure may help train immune regulation. But dirt is not medicine. Deliberately avoiding hygiene can expose people to genuine infections. The mystery becomes even deeper when evolution enters the story. Why would natural selection preserve such a troublesome reaction? One possibility points toward parasites. EG and mast cells can participate in defenses against certain parasites. Similar reactions may also help the body respond to venom or toxins. An ancient alarm system might therefore have offered useful protection. Modern allergens may sometimes activate parts of that old machinery. This explanation is intriguing, but it is not the entire answer. Evolution does not design perfect bodies. It modifies whatever already exists. A defense that occasionally misfires can remain, if it is usually survivable. Our modern surroundings may also differ sharply from ancestral environments. New foods, chemicals, pollution, and indoor lifestyles change what we encounter. Meanwhile, familiar allergies hide surprising details. People often say they are allergic to cat hair. The fur itself is usually not the main problem. Proteins from saliva, skin flakes, and urine can travel on it. Dust confuses us. Household dust is a complicated mixture. The actual trigger may be proteins from microscopic dust mites. Pollen allergies often change with seasons. Trees, grasses, and weeds release pollen at different times. Wind carries those tiny particles far beyond their source. Food allergies create some of the greatest confusion. Feeling uncomfortable after eating does not automatically mean allergy. Lactose intolerance usually results from difficulty digesting milk sugar. That process does not normally involve an allergic immune attack. Food poisoning is different again. It comes from contaminated food or harmful substances, not mistaken immune memory. A true food allergy can begin with a very small amount. However, the amount needed varies greatly among individuals. Online self-diagnosis can easily blur these distinctions. Even an allergy test cannot tell the whole story alone. Skin prick tests and blood tests can reveal sensitization. A positive result does not always prove that eating causes symptoms. Doctors therefore compare test results with a person's actual reaction history. Sometimes a supervised food challenge provides clearer evidence. Supervision matters because reactions can be unpredictable. Many allergic episodes remain mild and localized. A person may experience only itching, sneezing, or a few hives. Other reactions can affect several body systems at once. This severe reaction is called anaphylaxis. It can involve breathing difficulty, throat swelling, dizziness, or collapsing blood pressure. It is an emergency. Epinephrine is the first-line treatment for anaphylaxis. People prescribed an auto-injector need to keep it accessible. Emergency medical help is still necessary after it is used. Severity is not always easy to predict from a previous reaction. A mild reaction once does not guarantee another mild reaction later. That uncertainty makes a personal medical plan important. Fortunately, living with allergies is not simply endless avoidance. The first step is identifying the real trigger. Clear knowledge prevents unnecessary fear and unnecessary restrictions. Avoidance can then become specific rather than extreme. Antihistamines can reduce many effects caused by histamine. Other medicines help control inflammation in the nose, skin, or lungs. Their roles differ, so one treatment does not fit every allergy. For some conditions, allergen immunotherapy can gradually change immune responses. Carefully controlled exposure teaches the immune system to react less strongly. The process takes time. It must also be guided by trained medical professionals. Researchers continue exploring ways to prevent allergies before they begin. They are studying genes, skin barriers, diets, microbes, and early exposure. Every answer reveals another question. Why does one child outgrow an allergy while another keeps it? Why can an adult suddenly react to something once eaten safely? The immune system is constantly learning, adapting, and sometimes misreading signals. That is the central paradox. The same system that saves us from danger can also create danger. Allergy is not a battle against a powerful enemy. It is a powerful defense fighting the wrong target. The bodyguards are still protecting you. They simply need a better description of the suspect.